Hey everyone, today we are going to start using ratios to solve problems, and we are going to do that by creating tape diagrams. So in my first examples here, the first two at the top, we are actually going to just create tape diagrams. Excuse me. So example 1 says the ratio of smiles to frowns is 5:3. When I'm comparing these two things, this is a part-to-part comparison. Because I am comparing two pieces of a larger group. So smiles and frowns would be facial expressions. So I'm comparing the two things. And then my whole is going to be these two things combined together. So my whole is 8. Now in a part-to-part relationship, you want to make sure that you represent both parts in your tape diagram. A tape diagram is basically a long, skinny rectangle cut into pieces. So because my whole is 8 and I have 5 smiles and 3 frowns, I'm going to cut this rectangle into 8 pieces. You want them to look pretty equal, but they may not be perfect, and that's fine. Then what I'm going to do is I'm going to represent my ratio by drawing a line that represents the ratio at the appropriate point. So I'm going to count 5 boxes, 1, 2, 3, 4, 5. And I'm going to draw a line right here. And then I'm going to label. So the side with 5 boxes is going to be the smiles. And the side with 3 boxes is going to be the frowns. So my ratio is 5 smiles, so I have 5 boxes, to 3 frowns, so I have 3 boxes. In example 2, I'm going to talk about part to whole. So 2 out of 5 students. So this out of, right here, that's how I know it's going to be a part to whole relationship. So 2 is going to be the part, and 5 is the whole. That means when I create my tape diagram, I already know how many pieces it needs to be cut into because I know the whole amount. So 1, 2, 3, 4 is going to give me 5 boxes. And then after the second box, I'm going to do my little line break to show the first 2 and then the last 3. And then these 2 play soccer. Okay, so these 2 play soccer. And that means that these 3 don't play soccer. So in this one, I was already given the whole of 5. I had to break it into 5 pieces. And then these first 2 play soccer because 2 out of 5 students play soccer. And then I have to find what the other ones do. Well, if the first 2 play soccer, then the other 3 don't. So we're going to use both of these ideas, okay? And we are going to use tape diagrams to solve ratio problems. So I've got some steps here. So it says using a tape diagram to solve a ratio problem. And we're going to follow each of these steps as we go through the examples. So step 1 says determine your parts and your whole. Up here in the smiles and frown example, you can see that I labeled the 2 parts and then figured out what the whole was. And we're going to do that for each question. And then same thing for our part to whole. I have a part, I have a whole, what is the other part? Then I'm going to draw a tape diagram, just like I did with these 2, to represent the ratio with all the labels. And then in step 3 is when we start using the numbers they gave us in the problem. So they're going to tell us what the ratio is, and then they're going to give us some more information that's going to help us solve the problem. And then we're going to answer the question and include units. Okay? So example 3 said, Mrs. Nichols is buying flavored Tootsie Rolls for her class, and she wants the ratio to be 3 vanilla Tootsie Rolls for every 4 cherry Tootsie Rolls. Okay, so that's the ratio that I'm starting with. That's like the smiles to frowns or the 2 out of 5 students play soccer. Okay. This is a part-to-part relationship because I am comparing two different types of Tootsie Rolls, vanilla and cherry. So part 1 is going to be vanilla, and that one is 3. Part 2 is going to be cherry, and that is 4. So 3 vanilla to 4 cherry. And then my whole is going to be total Tootsie Rolls. And 3 plus 4 is 7. What that means is in my tape diagram, I have to have 3 boxes that represent cherry and 3 represent vanilla, 4 represent cherry, and 7 total boxes. So I'm going to draw my tape diagram. 1, 2, 3, 4, 5, 6 gives me 7 boxes. And then I'm going to, after the third box, draw in my line so that the left side represents vanilla and the right side represents cherry. Now we're going to use the next part of the problem. So it says if she has 42 vanilla Tootsie Rolls already. So on this side of the tape diagram, I've got 42 Tootsie Rolls, and I want to break it into 3 equal parts to fit in those boxes. 42 divided by 3 is 14. So I'm going to have 14, 14, and 14. And because it is a ratio and we write equivalent ratios, we either simplify or we have to multiply to get to the next part of the equivalent ratio. I'm going to use 14s all the way across. That's going to keep my ratio equal. So on the right side of this, I'm going to do 14 times 4 is 56. That tells me how many cherry Tootsie Rolls are on this side. And then I'm going to answer the question. It says, how many cherry Tootsie Rolls does she need to buy? Well, I'm going to answer that question as 56 Tootsie Rolls. Okay. This problem does say to create a tape diagram and a table. We are going to come back to tables. We're just going to work on the tape diagrams for now. So I'm going to go on to the next one. Example 4 says a survey showed that 3 out of 7 students in 6th grade like Michigan State. Okay, so this is my ratio right here that I'm going to use to create my tape diagram. This is a part to whole because of this right here. So when I label my parts and my whole is going to be 6th graders. One of my parts is going to be that they like Michigan State, so they like MSU. And then part 2 is going to be that they don't like MSU. So there's 3 that like MSU, and I've got 7 total 6th graders that make up my ratio. So there must be 4 that don't like MSU. So just like the last one was out of 7 boxes, this one is also only out of 7 boxes. So I'm going to draw my tape diagram. 1, 2, 3, 4, 5, 6. And then I've got, after 3, to draw my line. So these students like MSU and these students don't like MSU. So the next one says, based on this result, how many of the 146 graders don't like Michigan State? Well, they told me 6th graders. That means that that's the entire tape diagram. Okay. So that 140 makes up the entire tape diagram. So I'm actually going to divide by 7. 140 divided by 7 is 20. That means that each of these boxes is 20. And now we're going to answer the question. Based on this result, how many of the 146 graders don't like Michigan State? That's going to be this side of the tape diagram. So we've got 80 students who don't like MSU. So in this first one, example 3, it was a part to part, and you were given one of the parts. In this one, it's a part to part, and you were given the whole. Or sorry, this is a part to whole, and you were given the whole. Okay. I'm going to do one more. In this next one, it is a part to part relationship, and we are given one of the parts again. Or sorry, we were given the whole this time. So this says the ratio of time a student spends on science homework to the time they spend on math homework is 2 to 5. So I've got science, math, and total time spent. So they're spending 2 on science, 5 on math, and 7 total. That means when I create my tape diagram, it's going to be cut into 7 pieces again. Don't worry, they are not all 7 pieces. 1, 2, 3, 4, 5, 6. And after the second one, I'm going to do my break. So I've got science and math. Now it says the total amount of time the student spends on homework for these classes is 63 minutes. So it says total right here, total amount of time. That means the entire tape diagram is 63 minutes. And I'm going to break that 63 minutes into 7 equal parts. That means I'm going to put 9 in each of these boxes. And this one says, how much time does the student spend on homework for each subject? Well, that means I need to figure out science and math. So for science, they're doing these 2. And for math, they're doing these 5 over here. So 2 times 9 is 18. And then 9 times 5 is 45. So 18 minutes on science and 45 minutes on math. Okay, so this is a part to part where you are given the total amount and have to break that apart. I'm going to show one more example here because this is one of them that is made up of more than 2 parts. So this says a bakery sells fresh baked muffins sold in large or small boxes. A small box contains 2 blueberry muffins, 1 cinnamon muffin, and 3 chocolate muffins. So in this one, I've got blueberry, cinnamon, and chocolate. That means I have to add a third part. So I'm going to slide a part 3 in here. Because I've got blueberry, cinnamon, and chocolate, with my whole being total muffins. So this is a part-to-part ratio. That's actually a part-to-part-to-part because we're comparing 3 different kinds of muffins. It says the manager of the bakery wants to maintain the same ratio of each type of muffin in the large box as in the small box. Okay, so when we create our tape diagram, I've got 2, 1, and 3. So that's going to be 6 total boxes. I told you they weren't all going to be 7. So 1, 2, 3, 4, 5. And this time I'm going to have 2 lines. So I'm going to have 1 after 2 and 1 after the next one. So I've got blueberry, cinnamon, and chocolate. And it says, the manager of the bakery wants to maintain the same ratio of each type of muffin in the large box as the small box. If the large box contains 9 chocolate muffins, so I'm taking these 3 boxes and breaking up this 9. So 9 divided by 3 is 3. So I'm going to put 3 in all of the boxes to maintain my equivalent ratio. And then I want to know how many blueberry muffins are in the large box. So here's my blueberry muffins. There are 6. In the large box. Okay, so I've shown a variety of examples, and we are going to do some practice using the rest of the examples.